So, John, we're glad to have you with us. Please go ahead and take it from here.
Awesome. Thanks, Luke. And thanks everyone for joining today. Excuse me. Today, we're going to be providing a bit of a kind of a technical overview of Ansible automation. Real quick kind of overview of the agenda. It's going to be quite packed. So if you have questions throughout, as Luke said, drop them in that Q&A. Any questions that Alex can answer in real time, Alex, I'll ask that you do that or interrupt me if there's anything that seems pressing. Otherwise, we will have a little time at the end for Q&A, but let's jump right into it. We'll talk a little bit about, what problem is automation solving? I think that this is a bit of a no-brainer, but not only are we talking about solving a problem as far as automation, but we're also talking about centralizing and operationalizing our automation as well. We'll obviously get into what is Ansible, specifically Ansible Engine, which is a component of Ansible and Ansible Tower. Give a few example use cases, and then talk a little bit about some of the training options that we have at Red Hat available through Global Knowledge as well. And then, like I said, Q&A towards the end. First and foremost, we know that automation is happening. We know that if you are in any kind of role within IT, that you face a lot of challenges. Your effort takes time. Time is money. All these kind of old adages. But effort is a human toll. Or has a human toll, right? We are people. We're trying to work with other people. We're trying to cause these machines to do the work that they're capable of doing, so that we can prioritize what we want to do, whether that's building a new product, iterating on an existing process, all these different things that we want to do that we can't always do. Automation is really meant to make our jobs and our lives easier, and it presents an opportunity to do more. And we know that automation is happening in different silos. We know that there are teams that are organically already doing automation, maybe just not with the platform. My background, I supported system administrators for a few years. And so I know that they were building bash scripts, or maybe they were leveraging something like Puppet or Chef. I know that developers are, at least in my experience, usually the first of the table, working with maybe the upstream open source version of Ansible. Security teams often have different security scripts provided to them, maybe by a vendor. Same thing on networks. Network administrators are typically provided automation by their proprietary vendor they're working for. Cisco, Arista, Juniper. They have some kind of automation part of their portfolio as well. But is organic automation enough, right? If we have all these different teams, all these different lines of business that are automating, we know that they're probably not all automating the same way. We know that maybe not all of these teams are automating, and we know that the value of a tool, a product, platform, it's all dependent on what you can do with it, how quickly you can get your teams and organizations to the ideal state that you want to get them towards. And so our goal is really to help you to automate more effectively and more efficiently, more quickly. And so one that's helping more teams to automate, right? Bringing more of these teams into the fold so that they have an understanding of what tasks they can automate. So the second piece is we need to extend use cases, right? We can't think of automation as just a configuration, from a configuration standpoint or from an infrastructure standpoint. We have to start identifying across all these different lines of business, what can we automate? And we also need to make it easier to get started, right? We need to make it easier for all these teams to automate and communicate those automations to one another within your team and outside of your team. Just like with everything else, automation starts with one use case and then grows beyond that, right? When you start to look at even just, a system perspective, right? You start with maybe 100 nodes, and as you grow and scale, you find more use cases, you start to grow that infrastructure. Well, the same thing is going to happen with your automation, right? You're going to identify more problems that you can be solved quickly through automation. And that's really where Ansible comes into play. So Ansible, if you're unfamiliar, is a cross-platform automation platform. You dropped platform a couple times there. And, the reason that Red Hat acquired Ansible, and this would have been about 6 years ago at this point, is for really these kind of three key characteristics. And we'll dive into that, sort of the technical bits behind this in just a second, but we've really identified Ansible as being simple, powerful, and agentless. It's simple because it's human readable. It's written in YAML. If you're not familiar with YAML, it's a very, very simple markup language. It's a little particular about its formatting, but quite easy to understand. If you're a non-technical person, you can inspect an Ansible playbook, and we'll talk about what that looks like, one of these scripts, and really get the gist of what is actually being done. Maybe you wouldn't have the the skill set maybe right away to start building this automation, but you should be able to track it if you're an operations person, if you're a developer, understanding what's happening with this infrastructure focused or configuration management focused script. It's powerful because of all the different use cases. I talked about just a second ago, moving away from the idea that automation has to be something that's infrastructure specific or about deployment or about configuration management. One of the common questions that I get asked is, what's the difference between something like Ansible and Puppet or Ansible and Chef? And Puppet and Chef are fantastic configuration management tools, but their use cases really kind of stop there. Whereas with Ansible, we're trying to extend automation and this idea of kind of infrastructure as code or automation as code, across the entire organization and capture it all in one place. And then the last piece about it being agentless is largely about one, how Ansible works. So Ansible uses a lot of the same protocols that we would use to connect to systems anyway, things like SSH or WinRM, all the same tools. If you can access a system, Ansible can access that system, given the right privileges, credentials, and things like that. But there doesn't have to be an agent on those endpoints. So something like Puppet, up until recently at least, you had to have an agent on each of the systems or endpoints that you wanted to manage. And Ansible doesn't need that, right? All you need is access to that system via SSH if it's a Linux Unix box, or WinRM for Windows systems. And so again, really speaking to the use cases, a lot of different use cases outside of just configuration management. Ansible can perform provisioning, right? Provisioning systems from scratch, or provisioning your cloud, right? Auditing, compliance, security, obviously being a major focus for really all organizations, and Red Hat included there. Application deployment, right? Extending this this ability to automate to our developers and that developer community within our organizations. And it can also work on a bunch of different infrastructure outside of just what Red Hat provides, or outside of just Linux. So storage, networking, firewalls, load balancers. One of our biggest partners / competitors, VMware, right? Being able to automate across that stack, because we know that none of our customers are just Red Hat shops. It's going to extend well beyond our product portfolio, and we want to make sure that you're able to automate across all of those endpoints as well. And so again, we're talking about enabling all of these different roles throughout an organization to work together. We're trying to align the different roles of organization together so that they can embrace automation across the entire org, so we could stop automating in silos. We can contribute all of our automation to one central location where it can be operationalized, it can be scaled. And we'll talk in just a little bit about kind of the two different products within the Ansible portfolio. The first of which is Ansible Engine. And this is where we're actually creating, we're scaling, we're engaging. This is where we're running Ansible playbooks, which is basically the automation language that's meant to really describe the ideal state of your IT, application infrastructure, whatever it is. And then the second product, which we'll talk about, is Ansible Tower. This is a web UI that allows you to scale your automation and manage more complex deployments, speed up productivity, implement things like role-based access control, which we'll dive into in just a little bit. But this is kind of an overview of really the three different pieces. We're going to talk about Ansible Engine and Ansible Tower. There's also Ansible Hosted Services, which is essentially a repository of a lot of different. Think of it like our automation hub. This is where you can get access to a lot of existing automation. You don't have to start from scratch. But a big understanding of Ansible Engine and Ansible Tower is really key. So we'll dive into both of those pieces in just a second. I did want to show really quickly. This is just an overview of all the different technologies, or a sample of a lot of the different technologies that you can automate with. You can see there on the left side, across various private and public clouds. So AWS, Microsoft Azure, Google Cloud, all of the above there. The bottom left, you see different operating systems. So obviously RHEL, Linux is going to be included in there. Windows, being able to automate against, Windows Server, or even just, the commercial Windows offerings. Same thing you can automate across Mac OS. If you have a fleet of, systems that maybe your sales force are using or something like that, you want to be able to automate a lot of the different provisioning and configuration management of those systems when you are about to hand that over to maybe a new employee or it's a new laptop to them. And then in the middle there, I'll point out Windows networking. Huge opportunity for a lot of our customers who typically have a hybrid of Windows and Linux or Unix, multiple networking vendors throughout the environment. Being able to build automation to target all of these different operating systems, all of these different networking devices, all of these different storage vendors as well. And then being able to integrate that with a lot of your existing tools. So you can see on the right side, the security, the monitoring, the DevOps piece, being able to leverage a lot of the tooling that you're already using, being able to integrate that into some of your automation. An example, that we actually do internally here within Red Hat, we use ServiceNow for all of our ticketing. And over time, and I'll show kind of an example of what this looks like a little bit later on, we wanted to try to automate essentially maybe the top 10 most common tickets that were being opened. Maybe that means I can't access my email. And so by, previously what would happen, you open up your ServiceNow ticket, it's going to ask you a few required fields. What's the email address? What's your name? Things like that. And then somebody would manually have to go in and probably go through 3 or 4 different standard things they're always doing to make sure, hey, is this person's password locked out? Did they, for some reason, forget what their email address and this email doesn't exist anymore? Did this email address for some reason get shut down? Whatever it is that they were checking, we can now start to automate those things. So we can basically use ServiceNow as a place to input variables into Ansible playbooks that then kick off and run these kind of general checks. Then leverage something like Slack, you can see that in the very bottom right, to basically kick off a message. If after those 4 or 5 different standard checks that automation would take care of don't end up resolving the issue, have Slack kick off a message to somebody from our IT team to actually go through and start manually investigating. But at this point, the 4 or 5 most common reasons for this issue have already been investigated and shown to not be the case. And so really trying to streamline, just in this very specific example, some of our most common support issues so that our support teams can then really focus on things they really need to focus on. So, again, this is about automating technologies you're already using. This is about creating a predictable and reliable and secure experience for teams across your organization. So we're going to pivot a little bit and we're going to talk a little bit about Ansible Engine. Again, this is really kind of the language of automation. If you remember from this slide, this is the part that's simple, powerful, agentless. And this is really what is empowering development to production, from IT to the business, all of these different use cases, across all of those different lines of business. So a couple of things to point out, this is kind of just review of what we talked about before. It's cross-platform, human readable. Everything is written in YAML. And so this should be easy to build, easy to understand. Everything is executed sequentially, unless you go through and build out some, so you can make these things pretty complex. But for the most part, we'll show a couple sample simple playbooks a little bit later on. But these playbooks are meant to, from top to bottom, really be straightforward as to what it is that you're trying to accomplish. Are you spinning up a RHEL server and then creating some users and then adding a partition, or maybe configuring an NFS share on that system, right? Understanding what these tasks are that you would normally manually be doing, and then building out playbooks around those different tasks so that you don't have to do them, right? If you're ever doing a task more than once, that means that there's room to automate. A couple other things I'll point out from this slide. I talked about orchestration plays well with others, being able to orchestrate with other platforms using things, integrating Ansible into your ServiceNow ticketing workflows, but also, using things like AWS or Terraform as sort of your source of truth, right? If you've got 1,000 RHEL systems or just 1,000 systems, not even RHEL, deployed on AWS, and you want to be able to automate across all those different endpoints, you can use AWS to essentially serve as your source of truth and populate your inventory, your systems for Ansible to actually see. So it's really, really easy to integrate what you're seeing. But we'll talk a little bit about the way that Engine works. And in this slide, what you're seeing is really a diagram for Red Hat Ansible Engine. Again, this is the engine that's actually running the automation against these systems. And so we'll dive into what each of these different details, all these different components are and how they work together. First and foremost, there's the user, right? There's the administrator, the developer, whoever it is that's actually building the automation. You see that on the left side. And what they're building is an Ansible playbook. And what an Ansible playbook is that YAML text file that just shows a list of tasks in a specific order. And that's what Ansible Engine is then going to go execute. And so what you're seeing on this next slide is a sample example of one of these playbooks. So again, the formatting is a little bit particular. You'll learn YAML formatting pretty quickly. It's pretty straightforward, but it's a markup language, right? And so from top to bottom, what you're seeing here in an example is at the very top, the name of the playbook. This is the hosts that we're actually going to be targeting. So in this case, we have a separate inventory file where we have groupings, and I'll show what this looks like in just a second. And so we're automating against just our web servers in this case. So that might be one server, that might be 1,000 servers, we're not sure. And then the third directive there, become yes. Certain things on especially within Linux require you to have root user access. Excuse me. And so sometimes you have to essentially have privilege escalation built into some of your playbooks. Sometimes you want it to run as a specific user. Really what we recommend is you never run things as a root user, that you're maybe creating an Ansible user, a DevOps user, or you're using this become yes, which basically is equivalent to sudo. And all of this is really for logging purposes. When you log into a system directly as root, there are certain things that are not going to be logged versus if you're logged into a less privileged user. But in this case, what we're doing, and you see below that, the tasks directive, here we have 3 tasks that we're going to be actually doing. And so in this case, we are installing and starting the Apache HTTPD web server service on a Linux system. And so in this case, there are 3 tasks we need to do to accomplish that. For any of you system administrators out there, I know in your head, you're running through, these are the commands that I would need to run. I'd have to wait on this to happen, and then I'd have to do this and this and this. We're trying to streamline that into one repeatable process. And so we have 3 tasks. You can see that they're all named. Those names are an optional field, but very, very important to really communicate what it is that you're doing, right? You want to document this very, very similarly to the way that you would document, if you were a developer, document your applications. And so in this first task, we're actually making sure that the package, the service, is present on the system. We also want to make sure it's the latest version. And so what you can see, you have yum, that's the task, it's a module, I should say. We'll talk a little bit about modules in the next slide. And with that module, there are specific options. And a lot of these are optional. There's a way of, from either the Ansible documentation or from the command line, you can actually run and see a command of all the different required or optional fields for a specific module. In this case, what I'm saying is I want to download, yum is our package manager, package installer. I want to download this package named HTTPD, and I'm going to specify state, and I want this to be latest. I could specify in here present, I could say absent, like I don't want this package to be there. And basically what Ansible is going to then go and do is connect to my system, my web server system, and it's going to make sure that that package is present and that it's the latest available version to what I have available to me within our repository. Once it does that, it's going to move on to the next task. In this case, it's going to make sure that the index.html file, right? This is a web server. I need to make sure there's some web content there, is present. And so in this case, I have a file locally on the system where I'm running this Ansible automation, and I'm setting my destination as var www.html. It'll be index.html inside that directory. So basically, I'm just copying the file locally to those end systems. And then finally, I'm making sure that the service is started. That's this third service module here, making sure that the service, which is named HTTPD, the state is started. So pretty straightforward. I can run this against one system. I can run this against 1,000 systems. Obviously, if I do it against 1,000 systems, it'll take a little bit longer. But by the end, I should know that all 3 of these systems are going to be in that state. Now, one other thing I'll mention is that if at any point one of these tasks had already been accomplished, let's say I run this task and it connects to the first server and this package is already available on that system. It's already the latest version of that. It's not going to do anything. So this goes back to something we call idempotency or something called idempotency. If you're not familiar with that term, it's really the concept of only making changes when necessary. It's about achieving an ideal state and not making changes when you've achieved that ideal state. So theoretically, I could run this playbook once, potentially it's going to make a bunch of changes, or at least 3 changes across a bunch of different systems. If I run that same playbook again across all those systems, there should be no changes, no commands are run on those endpoints. I'm basically comparing what the ideal state is to what the current state is and only making changes if I need to. So it's a little less intrusive. You're going to find that, for a task like this, there's not really a lot of load that's being put onto one of these systems. But, as you start to build out these use cases and as your automation grows in complexity, you want to make sure that you're only running processes on these systems that may be production instances when you necessarily have to. So the next piece again is modules. I touched on this a little bit, but really there is a set of modules. They're largely either Python or PowerShell, written in Python or PowerShell. And again, think of these as essentially what you would be doing from the command line. There's a copy module which has a lot of the same options as the CP command would in Linux or in Unix, or I guess in Windows as well. And so, this is where, we ship thousands of modules, and we work with a lot of the vendors for vendor-specific modules as well. So for instance, Cisco or Juniper or Vios, there are going to be a lot of modules for configuring and or provisioning and configuring and checking for configuration drift against these different networking devices. There are going to be a bunch of different modules that we provide that we actually have worked with, Cisco and Vios and all these other vendors to actually build and certify. And so that running those commands against your Cisco router or Cisco switch or whatever it has been vetted by the right people. So a lot of modules, these are tools in the toolkit, right? This is what you are doing to actually build automation. And there are some modules that, when you can't find a specific module to do a specific task, there's like a shell module or a bash module where you can actually type in, the commands that you would run at the command line and integrate that into your automation as well. Plugins, think of these kind of as pieces of code that augment the core functionality. There are a lot of different handy plugins that we ship. You can also write your own. You can also write your own modules. I should say that too before the different tasks. So if there's a module or a task that you need to do and there's not a module to accomplish it, if you're a Python developer, you can actually build that module yourself. Filters are an example of a good example of a plugin. You can essentially just transform or format whatever data you're piping into it, into the filter. So, if you wanted to, your first task, gather information across, specific systems, maybe IP addresses, you could then filter, a specific subnet into a later variable to use later during your playbook. And then I mentioned inventories. So this is an example of what a simple INI format, essentially a static inventory file. So here you're seeing 1, 2, 3, 4, 5, 6, 7 different systems, 7 different endpoints, and you're seeing how they're grouped. So I have, web server 1 and web server 2 that are grouped in a web grouping. And if I go back to this playbook, you can see that my web grouping, this is what I'm listing here. Now I could list out a bunch of different host names, but it's really easy for me as I add web servers to just update this inventory file. And, as I scale, if I have 10 web servers, I just add web servers 3 through 10 here, run that playbook again, and it's only going to make the changes on web servers 3 through 10, theoretically, because it's already run this automation on web servers 1 and 2. Hopefully that makes sense. This is a static version of this file. You can be using a GitHub repository. You could use an external database. A lot of users depend on a dynamic inventory to import from existing tools like Infoblox or public cloud, which I mentioned before. Using that as your source of truth is totally fine. In fact, I think this next slide talks about that, where Ansible is capable of dynamically pulling inventory from existing cloud infrastructure or performing actions against those cloud APIs. So let's say you wanted to delete an AWS VPC or provision of virtual machine on Microsoft Azure. Ansible is capable of doing that as well. It's able to leverage and access those APIs on those public and private clouds in order to do a lot of different tasks. And then a couple more slides, and I saw there were a couple questions that had come in. Ansible can use a CMDB for inventory for variable storage. It doesn't have to be, or I should say Ansible does not have to be your source of truth. I've said that a few times now. You can rely on the other mechanisms that already exist within your IT organization. And then finally, there is obviously the infrastructure that you're actually performing automation on. All of that, this is kind of the ecosystem, right? So Ansible automation, there's hundreds of platforms. It supports from Linux infrastructure, VMware, Windows, network routers, switches, load balancers, IoT devices, wireless controllers, all of the above. There's so many different things we can automate against. And really the idea is how many different tasks can we build out around this as well? I believe that everyone will get a copy of the slides afterwards. Luke, correct me if I'm wrong there, but I'll leave this up just for a second. The GitHub repository for the Ansible team has a lot of awesome examples around ways to get started. If you're an Ansible customer, you should have access to our Ansible Hub as well. Think of that as kind of a supported Ansible repository with a bunch of different playbooks and projects and things like that, different workflows that you can build from or just take wholesale, which is usually what I do. And so you have access to a lot of that within the GitHub pages, the public GitHub pages, and obviously if you're an Ansible customer through Ansible Hub as well. So I'll pause there. Yeah, go ahead, Luke.
Great pause. Yeah, I was just going to let you know you are correct. There will be a slide deck PDF and the recording sent out in about a week. So thanks, John.
Perfect. So yeah, those links will be in there. And then I did want to, I'm having a hard time viewing the Q&A. So I don't know.
I can read it to you, John.
Yeah, go ahead.
It says, does Ansible support ACF2 or ACF-OS?
I don't, ACF2, I'm not sure. Let me do a quick Google. I don't think so. But I'll have to get back to you on that. Honestly, I'm not 100% sure. I don't think so. Now, again, just because it's not supported by Red Hat doesn't mean that there isn't automation that exists out there. In addition to what we ship and support, there is this enormous open source community. Specifically, if you go to that GitHub page or if you go to Ansible.com, if you're unfamiliar with Red Hat's model, we are shipping and supporting essentially enterprise builds of a lot of these open source communities that we're major sponsors and participants in. And so using, or I should say, taking advantage of a lot of those different open source communities, if there is something that can be automated that we are not shipping or supporting, that does not mean that's the end all be all. I'll just leave it there. Now, obviously, having to rely on open source communities for support versus being able to rely on Red Hat is obviously a bit of a concern or a hurdle. But definitely, just because Red Hat doesn't have support, and I won't even say that. I would have to do a little bit more research, but I think the answer is no. All right, we're going to transition now into a little bit around Ansible Tower. This is kind of the other piece of that. This is where things, I think what we say is control, knowledge, and delegation is or control, scale, and delegation are kind of the three key tenets to Ansible Tower. This is, again, where we're really scaling. This is where we're operationalizing. If Ansible Engine is where the playbooks exist, and this is the engine, or I should say how we're actually describing infrastructure, Ansible Tower allows you to really scale our automation. It allows us to have more or to manage more complex deployments. It allows us to speed up productivity. So first and foremost, think of Ansible Tower. It's really just a web UI. It is a web UI with a RESTful API as well, which allows you to, again, really scale your automation across multiple teams. I would say when there's more than one team that's automating and you want to centralize this, this is really where Ansible Tower comes into play. Some of the things that Ansible Tower, and I'll jump into these a little in depth in some future slides, but role-based access control, RBAC, is a really, really important feature with this, allowing you to control, keep environments secure, teams efficient, saying that only these users have access to run these specific automation scripts on these specific systems, being able to implement a lot of different roles and making sure that only the people who should have access to specific scripts or to specific systems have that access, making sure that non-privileged users can, safely deploy applications with push button deployment, making sure that there's a place where all this automation is actually being centrally logged. Although we'll talk kind of a caveat of that in just a second, a good caveat. But again, this is really where you're centralizing and controlling your infrastructure. There's a visual dashboard where, all the different, and you can see kind of what that looks like here on the right side. This is the home page. When you come in, you're going to see at the very, very top, all of the hosts that you have across all of your inventories. Now, I talked before about static, static inventories where you're kind of creating an inventory file yourself. When you've got 3,700 hosts, you need to be able to rely on those different sources of truth, whether that's Red Hat Satellite, AWS, another public cloud, or ServiceNow, or something like that. So, being able to leverage that. You can also see failed hosts. That means systems that Ansible wasn't able to connect to. And that's across 3 different inventory files, multiple projects. I can see all the jobs that have been run across the last 24 hours, or obviously I can change that time period as well. And then in the bottom right, I can actually see the recent jobs that were run and if there were any errors with that job. So, as an operations team, being able to actually view all this automation, see where there are issues, and then kick that back to, the respective teams if necessary for investigation. So this is a lot here. I won't even spend too much time on this. You can see that Ansible Engine and Ansible Tower really are just kind of a piece of this. The automate your enterprise piece that you see below this just goes back to what we were talking before, where you're able to automate across all of these different systems. Engine being the language of automation, Tower providing that GUI for launching and managing all of these different tasks. And you can kind of group them into jobs, which execute instructions that are contained within these playbooks. Tower plays a really key role of applying things like role-based access control to the execution of these jobs, so that we're ensuring that you have the proper level of access, and then also implementing that browsable API that allows Ansible to integrate with those existing enterprise services you already have, whether it be ticketing or authentication or logging or monitoring. But a lot going on here. And then that doesn't even include things like the Automation Hub, Automation Analytics, Services Catalog, which is all part of the subscription. Job templates are a really, really big piece of Ansible Tower as well. Being able to essentially create a template tied to specific, and we say jobs, we're talking about playbooks really, but being able to essentially have a template so that we're only running a specific playbook against a specific system. Sometimes this is, in this case, this is an Azure Linux VM spin-up. So basically I can have this here. You can see in the top right, this little blue icon that says edit survey. I can actually, if I want to associate a survey to a template where, let's say I wanted to solicit, what does the user need to be named for this? What services need to be pre-installed on this virtual machine? What endpoint, where do I want this deployed? All these things that I might consider as part of my virtual machine deployment, I can actually create a survey so that as somebody clicks the button to actually run this template, run a job from this template, that a little pop-up comes up where they have to then input specific things like, the username and password that's going to be created on launch, or, if it's Azure, what data center is this being pushed to? If I have, kind of an east and a west deployment or something like that. So, being able to make these complex and also solicit information from the person who's actually running the job. We talked about inventories a little bit, but having a graphical way of building out and managing these inventories, this behavior is identical to what you would be able to do from the command line. But I think that there are, just like with learning, there's visual people, there's people that can do it from a command line, people who need to see a web UI. So having that integrated straight into a tower makes this really easy for a lot of people. Talked a little bit about the credentials, but being able to integrate credentials that you're used to, whether it be an SSH key or a token, or integrating with existing credential management tools, things like HashiCorp Vault or CyberArk, or your LDAP, IPA server, being able to integrate all the same kind of security and authentication protocols you have in place now, being able to integrate that with towers so that you are not sacrificing anything for what you're gaining. I mentioned the RESTful API as well, but being able to leverage this with your playbooks, being able to leverage this with a lot of the existing services that you already have in place as well. This is a JSON output. I think you can actually get this as a, if you wanted to, as a YAML output as well. But I think most developers typically more used to the JSON output. Touched on role-based access control as well, but being able to essentially assign users to teams or organizations and have those tied to specific job templates, or they can only run, they cannot create, right? We actually just within the last year or so created a new auditor type, which can see all aspects of automation, but has no permission to actually run or change the automation for those that need kind of a system level auditor role in place. But then there's administrators who can build and assign groups to roles. There are ways of having somebody only be able to execute against specific systems, or only be able to execute specific projects. All that really being extremely key. And then I touched on this before, but centralized logging, obviously logging provides the capability to send really detailed logs and have that all kind of centrally managed. But you can also, if you're already using a third-party external log aggregation service, plug that in as well. We have on the right side Logstash, Splunk, Loggly, Sumo Logic as some examples. But the types of data that are most useful to Tower are job fact data. What was the job successful? How many times was it run? Were any errors come up? Did any errors come up? The log messages that come from a successful or a failed job run all needs to be centrally located, so that your system administrator, your developer, whoever it is that needs to then investigate, has access to all of that. And so when you're using a log aggregator, it basically just it takes the log data in JSON format, sends it over an HTTP connection to use a really minimal service-specific tweaks that are engineered in kind of a custom handler or via an imported library. And so Tower basically, as it sends that information over, then deletes it or uncaptures it, I think is the term that we use, locally, or saves it if the log aggregator is down as well. And then the last thing I wanted to touch on before we jump to the training piece, I know we're coming up towards the top of the hour, job workflows. So having one specific playbook to do a specific task is great. And that's really where we all start. We identify a specific project that we want to be able to automate. We build, a playbook, or maybe a series of playbooks. But a lot of the times these playbooks can be part of these more general sequential workflows. So I'll give you an example. Let's say you have an application that you want to deploy. You need to deploy it to a test environment first and run a few tests across that. That test environment is a clone of a production environment that we have. And so maybe the first part of this chain is actually cloning that production instance and spinning up a test environment that is identical. So maybe that's one playbook. That could then move into the second part where you're now having to deploy the application and run a couple tests on that. From there, maybe you have a split, right? So you can see here in the examples that, sometimes 2 plays will funnel back into 1. You can also have 1 play funnel out into 2 based on the results that you're getting, right? And so maybe you run these automated tests against your application, and they pass, and so that goes up towards now I need to deploy to production. But maybe those tests failed, and that goes down where now it alerts the developer to then go and investigate and kind of start the process over again. In that first example, the tests succeed. Well, now it's going to start of a chain where, if we have 100 systems in production that I need to move this application onto, maybe what it does one by one is, or in groups, maybe, take 10 of those systems off the load balancer and deploy the application and then re-add them to the load balancer, right? So, as you can start to think of some more complicated jobs that are kind of a part of larger workflows, you can really easily start to build these out and build logic into a lot of these different pieces as well, so that, at any point along this workflow, you can see, are there errors? Is there failover? Is this broken down so that at any given situation, it's going to kick off another job or at least alert me to the error? So I did want to really quickly jump into a couple different use cases. You can see some example use cases here as well. On the Linux automation side, and honestly, this is a bit of an outdated slide. I think we're closer to 250, maybe even 300 modules at this point, just for Linux. And so that's system modules, packaging modules, file modules, command modules, clustering modules, really giving you the ability to automate every task and process on Linux. That link down there at the bottom, again, you'll get the copy of the slides after this. We'll give you a lot of different kind of example use cases as well. In this situation, and I should preface this is not something that we would ever recommend doing in a production system, but let's say you just wanted to upgrade all of the packages on a system to the most latest version. This would be a really easy way to do it. You target all of your RHEL systems. You're again using that yum module. The name, we're just putting an asterisk in there, so it's going to grab every package and it's going to make sure it goes to the latest version. Again, I would not recommend that in a production environment, at least. And then same thing, right? I need to maybe create a second play after all of that. Have one play that goes through and updates all of these packages. Have that kick off maybe in a workflow. A second play where it actually reboots the system, because I'm going to assume that there are going to be maybe a kernel update in there, and I need to make sure that I'm rebooting the system so that it boots into the latest version of the kernel. And then here's a third example where we're just making sure that a specific service is started. So this is very similar to the example we provided before. I would highly encourage that one of those early slides that has a lot of the different example playbooks to go through, because there are some very complex examples we could provide, but we could probably spend an hour just going through one of the playbook examples on that website. On the network automation side, another really big example, we have Ansible modules across 65 plus platforms, over 1,000 network modules. Again, I think these numbers are out of date as well. Really, the takeaway is that Ansible network modules make up about 1/3 of all of the modules that we actually ship with Ansible. And so it's a significant part, and we really try to leverage our existing relationships with each of these different networking vendors, because ultimately it's their hardware, right? And so we want to make sure that they have a seat at the table in building automation against it. And so here's kind of a sample example here. What we're doing is probably what any network engineer is doing, multiple times a day across their systems. They're just getting a show command. They're running show commands against, all of their Cisco hardware here in this case. I think just to make sure that all of these different devices are up. So you can see here, this is what the output would look like across that system. We've just run our Ansible playbook command with this example YAML file across 2 routers, it looks like. And we're getting some information just displaying the result. This is essentially the equivalent of the show command on those routers if we were just doing this straight from the command line. And so I can see here, the interface names, I can see the IP addresses, I can see that their status is up. Because it's not making any kind of a change, you can see there at the bottom, the play recap, that everything's okay, because I'm just doing a passive command, right? I'm just running a show command, so nothing's being changed. This is the exact same task now, just with a Juniper device. So we did Cisco in the first example, Juniper in the second example. Again, we're just running a show command for these Juniper routers, or I think they're switches maybe in this case. No, they're routers again. And so again, exact same kind of desired output. Obviously, the output itself is different because it's a different, different vendor's router. But again, I can do this, a certain amount of times, and if at any point it's unreachable or it failed because that system is not able to, or that router is not accessible, I'll get a notification of that right away. And so, these are really where those different workflows can come into play. I can create a workflow to essentially monitor if these routers are up, maybe once every 10 minutes, once every minute, once every hour, whatever interval that I want to do it. And if at any point it comes back and it's not okay because it was able to successfully run that command, I'll get a notification. So, being able to build logic into that. And then finally, I also, because I talked about it a couple of times, I wanted to include a slide in here around the ServiceNow integration. This is basically what this looks like internally for us. And so every time somebody creates a ticket with ServiceNow, this is what's happening on the back end. And so the username, the password, the instance, the severity, the priority, these are things that are being provided by the person when they're opening up this ticket, right? And maybe, the IT person goes back and they change the severity, they change the priority based on the actual issue. But all of this is what's what's happening on the back end. So all I'm seeing as an end user is the ServiceNow page, our instance. And as I'm entering in my information, I'm putting in my short description, blah, 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 blah. It's then on the back end going to create my ticket for me with the notes that I provided that I can then access again through that ServiceNow website. Maybe on the back end, what it's doing is actually kicking off a job to actually go through and try to do some automated remediation of my issue before notifying somebody. And so for this specific playbook, when we run this is what it's going to look like. You can see there's a couple things that were changed, a couple things that were, or one thing that was changed, a couple things that were just passive. In this case, the task to actually create the change request, so creating the ticket itself, was a change because it didn't exist before. And so you can see here on the local host, there were three pieces that were just okay. So no changes had to be made by those tasks, but one task did create a change. If I ran this exact same playbook again, because it's ServiceNow, it would just create a new ticket. But theoretically, if it was any other kind of automation, again, you would just see the second time around that nothing would be changed because it had been done before. So we are going to now pivot a little bit into talking a little bit about some of the training options that we have specifically around Ansible. If you're not familiar with Red Hat training, we offer a variety of different ways to get trained. Primarily, or I should say previously, prior to COVID, we did a lot of in-person deliveries, whether privately via an instructor coming to your location for your team, or in a public setting in one of our classrooms located around the country. Global Knowledge, a big partner of ours, was one of those kind of in that facilitator standpoint. They have classrooms you can go to, things like that. Obviously, with COVID, we've really shifted everything to be virtual. Now, luckily, we've been doing virtual training for several years now, and so we were able to, really kind of hit the ground running. We didn't really have much interruption as far as that goes, and so now our private and our public classrooms are both available virtually. You can have live instructor-led training, whether for your entire team in a private setting, or one of our open enrollment kind of classrooms, again, virtual. And then we do offer a few different ways to do self-paced training. If you're interested in just a single course, we do offer 90-day access to any one of our courses. With any way that you train, there's a heavy focus on hands-on labs. And so we actually provide a lab environment, whether you do instructor-led training or self-paced training, so that you can actually get your hands on keyboards. You can actually start doing the things that we're talking about within the class. And then for those of you that might be interested in something a little more long form, maybe you're interested in taking a couple courses, but you can't put the time aside to do a full week engagement in a classroom. We do have a Red Hat Learning subscription. This is a 1-year subscription to our entire course portfolio. Provides you, again, full access to all of the courses, including 5 or so Ansible courses that we have in our portfolio at this point. But also includes Red Hat Enterprise Linux, OpenShift Container Platform, OpenStack, all of our products. And again, we're providing also a lab environment where you can actually go through and practice all the things we're talking about. Now, one thing that we've actually just introduced is kind of a hybrid of that self-paced and instructor-led training. And that's our Red Hat Learning Subscription Premium. Essentially, we're taking our standard Red Hat Learning subscription, getting access to all the courses, the labs, you get access to an instructor for office hours if you have questions about what you're learning about, but also having virtual training embedded within that, where instead of taking a 5-day course, you can sign up actually for a 3-hour session that's just going to cover maybe a specific chapter, maybe 2 chapters of a course. And so, as you're learning, if you realize you're starting to encounter parts of the course that you're having trouble with, and an instructor office hour session isn't going to cut it, you could set aside the 3 hours and go through one of these instructor-led trainings. And so that's the the big kind of difference with the premium tier. Quite honestly, it's exactly what my learning style is. I typically don't want to go through an entire course, but sometimes it's nice to have an instructor to bounce off of in real time. As far as the Ansible training that we provide, we have several courses where you can start. I would encourage you, if you are looking for something a little more technical to start with, just to kind of whet your appetite, we do offer a free technical overview that's actually delivered by one of our instructors. It's the DO007. It's probably the coolest course code that we have. That is available on the Global Knowledge website. Work with Luke and team to get access to that. But from a training perspective, we really have 3 entry points for you to understand how to get started with Ansible Engine, right? Actually building out automation across a few different endpoints. We have a network administrator focus course, a Linux administration focus course, and a Windows automation focus course. All of them really teaching you sort of the same concepts. This is how to build playbooks. This is how to manage inventories. This is how to automate across some more complex different use cases. With our Linux administration course, we do have a follow-on course that gets a little bit deeper into service management, gets into some more advanced networking as well, and how to automate, specifically deployments of a lot of different services that run on top of Linux. And all of that funnels down into our advanced automation course that gets a lot into Ansible Tower, as well as how you implement like a CI/CD pipeline, how we can implement things, infrastructure as code as a general philosophy. So, want to make sure that everyone has exposure to that. Luke and team at Global Knowledge will be able to take care of any needs that you have, whether it be one of these individual courses or the learning subscription. You can reach out to Luke and team at Global Knowledge for any questions as far as that goes. But with that, I did want to kick it back to you, Luke. I know there's a couple things that you wanted to touch on before, if we have any other questions.
Thanks so much, John and Alex, both of you, for being with us. Grateful for the time, and once again, lots of super helpful information. If we can be of help to you at all into getting into some of these Red Hat classes, as John said, please feel free to reach out to us. You can go to globalknowledge.com and also take a look at a lot of webinars, use cases, courses, white papers, just a lot of helpful information related to Red Hat and related to other technologies as well. So with that, John, if you don't mind skipping to the next slide, just some ways that you can reach out and contact us. Wanted to make sure that you saw that here. So again, John, Alex, thanks for being here. Thank you all for attending, and have a great rest of the day.